Alright, welcome to 4.4, Composition of Transformations. All that means is now we're doing more than one transformation at a time. We're putting the last three sections together, all on one page. So our goal, or our learning intention for today, I am learning how to perform a composition of two or more transformations. Today we're just dealing with two on a figure and explain how each step changes the figure's size, position, size, or orientation. Well, today, all we're dealing with is 2, and then position and orientation. Everything we're dealing with right now is a rigid transformation. We have not dealt with anything that actually changes the size. It may be turned, it may be flipped, it may be slid, but we have not changed the size of anything yet. These are pretty much the same thing. There's a typo here. Sorry about that. I can accurately identify sequences of transformations, and this one should just be I can perform. So we're going to get rid of that. We're going to get rid of that. It just shows that you need to check your work before you print them all out. So we're going to take a shape, an original shape. We're going to do one transformation on it. We're going to do a second transformation on it, and then we're going to be done. So I'm going to go through this first one again. There's nothing new on this page. We're just doing multiple things together. I'm going to show you what that means. So we start with triangle X, Y, Z with vertices -3, -3, 7, not -3, -7. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. -5, 2. And -2, 1. I skipped around a little bit, not sure why, because I can read real well. So we're at X, Y, and Z. The first transformation we're going to do is a reflection across the X-axis. So again, X-axis, that bold line right there, we're going to flip it down here. Do we remember what our rule was for a reflection over the X-axis? What has to change? We get a -y. So our new X is going to be what? X stays the same all the way down, so we can fill that in. -3, -2, -5. But the Y's have to change. It's going to become a -7. -1, -2. So if we were to graph that out, we're at -3. So 1, 2, 3, -7, -2, -1, and -5, -2. X prime, Y prime, Z prime. And we're done, right? Nope, because we have another one to do. Now we're going to do a translation along the rule XY becomes X plus Y, Y plus 2. That's what we're going to do to our new set of points. It doesn't go to the original. It goes to our new one. So we first had to reflect it, now we're translating it. So now we're going to add 9 to all the X's. We're going to add 2 to all the Y's. Our original was XYZ. The reflection was X prime, Y prime, Z prime. Now that we're doing a second transformation, our figure is going to be X double prime, Y double prime, and Z double prime. So we're going to figure out our new points. -3 plus 9 gives us 6. -7 plus 2 gives us -5. -2 plus 9 gives us 7. -1 plus 2 gives us 1. -5 plus 9 gives us 4. -2 plus 2 gives us 0. So we're able to graph these new points. 1, 2, 3, 4, 5, 6. Down 5. 1, 2, 3, 4, 5. 7, 1. 7, 1 is up here, and 4, 0. Where did I go wrong, guys? Can I add? Yeah, I added everything, right? Oh, that's because these originals were wrong. Okay, go me. So, again, you guys didn't tell me I graphed this wrong. Like it never even happened. Who was it? Bob Ross that said mistakes are never permanent or something like that? I don't know. X double prime, Y double prime, Z double prime. We all make mistakes, but as long as we can figure out how to fix them, we're all good. So, I want you to try number 2 right now. Triangle GHI. You're going to translate along this vector. So again, we kind of just traded spots here. Instead of translating first, or translating second, we're going to translate first. And then reflecting on the line y equals 3. It's a little bit different, but it's still a translation and a reflection. When we come back, we'll see if we have the same answers. So I'll go and pause the video, give number 2 a try. How'd you do? If you forgot how to reflect across line y equals -3, go back in your notes. That's what they're there for. That's why I let you use them on the tests, because we are still learning these things. Don't expect you guys to be experts right now, but I do expect you guys to be able to use your notes. None of this is new. We're using the old stuff, so wouldn't it make sense to use your notes? Yeah. So, we had our original. We translated along this vector, meaning we added 7 and subtracted 5 from all the y's. So you should have gotten 6, 1, 6, -2, 1, 1. Then you reflected across y equals -3. So that's that straight line going across. Y equals -3. We're flipping it. It's kind of like the rotation about a certain point where you're trying to figure out how far away is it from that line. So, for example, H was 1 away. So we just went 1 the opposite direction. G was 4 away. So we went 4 the opposite direction. I was 4 away. So we went 4 the other direction and got our new points. Okay. We're going to do number 3 together. Then you're going to do number 4 all by yourself because I know you guys can do it. Parallelogram CDEF. We're going to reflect it and then translate it. So we've got 2, -1. We've got 7, 1. We've got 6, -2. And we've got 1, -4. That gives us C, D, E, F. We're looking for our first prime. So again, reflected across in the line y equals x. If you forgot how to do y equals x, switch x and y. All we gotta do is flip all our points. So C was 2, -1. Now it's -1, 2. D was 1, 7, or 7, 1. Now it's 1, 7. It was 6, -2. Now it's -2, 6. It was 1, -4. Now it's -4, 1. Let's plot that. -1, 2. 1, 7. -2, 6. 1, 2, 3, 4, 5, 6. And -4, 1, 2, 3, 4, 1. That gives us C prime, D prime, E prime, and F prime. Now for double prime, C double prime, D double prime, E double prime, F double prime, we are translating along the rule -3 minus 7. So we're going to take all of our points. We're going to subtract 3 from the x's, subtract 7 from the y's. So -1 minus 3 gives us -4. 2 minus 7 gives us -5. 1 minus 3 is -2. 7 minus 7 is 0. -2 minus 3 is -5. 6 minus 7 is -1. -4 minus 3 is -7. And 1 minus 7 is -6. Plot your new points. So we're at -4, so 1, 2, 3, 4, 1, 2, 3, 4, 5. Then we're at -2, 0. Then we're at -5, -1. 1, 2, 3, 4, 5, -1. And then we're at -7, -6. So down here. That gives us C double prime, D double prime, E double prime, F double prime. Yes, you are graphing 3 things each time. You'll survive. I want you to give number 4 a try by yourself. Pause the video. Let's see what you can do. So, how'd you do on this last problem? 270-degree counterclockwise rotation with a point -1, -2. You had to find all of the vertex form from point P to B, C, D, and E. 270 degrees, meaning you flip your points, make the second one negative. So, flip and make the second one. That made everything negative. And you applied that to point P, not the original points. I bet some of you did it to the original points. Remember, it's to point, we're going to call it P. It didn't say point P, but it's always been point P for us. So that gave us 0, -3, -1, -7, -3, -8, -2, -4. Then we translated along the vector 0, 8, which means we kept the x the same because that was +0, and then +8 to all the y's. So we got our new points. Once again, composition of transformations. They can use any combination of reflections, translations, rotations when they do this. Later on, we're going to add another type of transformation, which will change the size, which again will make things a little bit different later on. But for right now, this is what you got. This is the end of 4.4, which you should now be able to do all of the 4.4 assignments on ALEKS. If you have any questions, please make sure you're asking. Good luck.